transport vessel Convergence dropped out of hyperspace with a mechanical shudder that rattled through the hull. Commander Zeth Kalar's 4 eyes swept across the bridge displays, noting the successful arrival at Kepler 442b, a barren world selected for this cycle's survival assessment. The planet below showed nothing but endless stretches of red dirt, scattered rocks, and a thin atmosphere that would challenge even the most advanced life support systems. All cadet teams, prepare for planetary deployment, the commander announced through the ship's communication array. This is your final examination before graduation from the Galactic Military Academy. You have 72 standard hours to establish a functional shelter, capable of sustaining life for 1 full rotation cycle. In the cargo bay, 24 cadets from 12 different species checked their equipment packs. Each team had been issued identical survival kits containing a portable fusion reactor, atmospheric processors, nanoconstructors, and enough raw materials to build a standard military outpost. The technology represented the pinnacle of galactic engineering, devices that could transform hostile environments into habitable spaces within hours. Marcus Chen stood beside his assigned partner, a tall Vorthak named Crixvel, whose scaled skin gleamed under the artificial lighting. The human appeared unremarkable compared to his classmates' impressive 7-foot frame and natural armor plating. Where Crixvel carried advanced scanning equipment and wore environmental protection gear, Marcus had only basic atmospheric mask and standard-issue coveralls. Your species always seems underprepared for these assessments, Crixvel observed, his translator device rendering his clicking speech into standard galactic. Perhaps you should have requested additional equipment allocation. Marcus shrugged, adjusting the simple tool belt around his waist. Sometimes less is more. We'll see how it goes. The other teams were already displaying their sophisticated gear. The crystalline helix pair had brought geometric habitat modules that could self-assemble into complex structures. The Zephyrian team carried gravitational manipulators capable of reshaping terrain. Each species had selected technology that complemented their natural abilities and evolutionary advantages. Deployment commences in 60 seconds, came the announcement. Teams will be distributed across the planetary surface at minimum distances of 50 kilometers to ensure independent operation. Communication between teams is prohibited until the assessment period concludes. Through the observation ports, Marcus could see the planet's surface rushing up to meet them. The landscape looked harsh and unforgiving, with jagged rock formations jutting up from flat plains of rust-colored soil. Dust storms swirled in the distance, and the thin atmosphere created an alien sky that shifted between orange and deep purple. Landing zone approached. All teams to deployment pods. Marcus followed Crixvel into their assigned pod, a sleek vessel designed to deliver them safely to the surface. Around them, other teams were making final equipment checks and reviewing deployment strategies. The excitement and nervous energy was palpable as 2 years of academy training came down to this single test. The pod sealed with a soft hiss, and Marcus felt the familiar sensation of artificial gravity shifting as they separated from the mother ship. Through the small viewport, he watched other pods streaking toward different sections of the planet like falling stars against the alien sky. I have calculated optimal shelter placement based on terrain, analysis, and atmospheric readings, Crixvel announced, manipulating his scanner with practiced efficiency. The fusion reactor will provide primary power, while the nanoconstructors can fabricate habitat walls using processed soil compounds. Standard deployment procedure should have us operational within 4 hours. Marcus nodded, though his attention was focused on the landscape below, rather than the equipment readouts. He was studying the way the wind carved patterns in the dirt, how certain rock formations seemed to channel airflow, and where natural depressions might offer protection from the dust storms that periodically swept across the plains. The pod touched down with a soft thud, and the door cycled open to reveal their new home for the next 3 days. The air was thin but breathable with their atmospheric masks, and the temperature reading showed it would drop significantly once the distant sun set. Most teams would rely on their technology to create enclosed, climate-controlled environments that could maintain perfect conditions regardless of external weather. Crixvel immediately began unpacking their equipment, laying out components according to standard procedure. The fusion reactor hummed to life, providing clean energy that could power their systems indefinitely. The atmospheric processors started working to create a small bubble of optimal air composition around their landing site. I will begin soil analysis for the nanoconstructors, Crixvel said, taking samples with a sophisticated probe. The fabrication process should commence within 30 minutes. Marcus stood at the edge of their designated area, looking out across the barren landscape. In the distance, he could see other teams beginning their construction projects. Bright lights appeared as fusion reactors came online, and the geometric shapes of advanced habitats started taking form against the alien horizon. "Marcus," Crixvel called, "are you not going to assist with equipment setup?" The human walked back to where his partner was arranging their technology in neat rows. Everything looked efficient and properly organized, ready to create a shelter that would easily pass the Academy's survival requirements. It would be enclosed, comfortable, and completely dependent on continued operation of their advanced systems. "Actually, I think I'm going to try something different," Marcus said. Kneeling down to scoop up a handful of the red soil, he let it run through his fingers, testing its consistency and composition by feel alone. Different? The procedures are quite specific about optimal shelter construction methodology. Marcus started walking in a wide circle around their equipment, studying the ground and occasionally stopping to dig small holes with his hands. "The tech will work fine as backup, but I want to see what this place can teach us first." Crixvel's translated confusion came through clearly in his tone. "Teach us." "It is a barren world selected specifically for its lack of resources and hostile environment." "Maybe," Marcus replied, now examining the way dust accumulated against some rocks while flowing smoothly past others. "Or maybe we're just not looking at it right." While Crixvel continued setting up their standard equipment array, Marcus began what his partner considered an increasingly bizarre investigation of their immediate surroundings. The human had stripped off his environmental suit jacket and was now crawling around on hands and knees, pressing his ear to the ground and tasting small amounts of soil. "Marcus, your behavior is highly irregular. The atmospheric composition requires proper filtration, and direct contact with unknown soil compounds poses contamination risks." Marcus stood up, wiping red dust from his hands. "This dirt isn't unknown. It's iron oxide mostly, with some silicates and organic compounds that got deposited here over millions of years. I can work with this." "Work with it?" "The nanoconstructors will process the raw materials into construction components according to molecular specifications. Manual manipulation of base elements is primitive and inefficient." "Primitive, maybe, but this planet has been shaping and reshaping this material for longer than any of our species have existed. There might be something to learn from that process." Marcus had noticed something the scanners missed because they were looking for technological solutions rather than natural patterns. The rock formations weren't random geological accidents. They were evidence of how this world handled its environmental challenges. The way certain stones had been carved by wind and weather suggested specific properties. Some absorbed heat during the day and released it slowly at night. Others channeled airflow in ways that could be redirected for cooling or heating. Around them, other teams were making rapid progress. In the distance, the crystalline helix pair had already erected their geometric habitat, a perfect dodecahedron that gleamed with internal lighting. The Zephyrian team was using gravitational manipulators to carve their shelter directly into a hillside, creating smooth walls that would require no additional structural support. Crixvel activated their nanoconstructors, which immediately began processing soil samples and extruding standardized building materials. "Our fabrication rate is optimal. The shelter structure will be complete within 2 hours, fully climate-controlled and equipped with all necessary life support systems." Marcus was now collecting specific stones, testing their weight and examining their surfaces with intense concentration. "These rocks have been tumbled by wind for centuries. Look at how smooth they are, but only on certain faces. The rough sides would have been protected somehow. I fail to understand the relevance of geological formations to our survival." Assessment: "The planet has already solved every problem we're trying to fix with technology. We just need to figure out how it works." Marcus began arranging his collected stones in a rough circle, fitting them together like pieces of an ancient puzzle. His movements seemed random to Crixvel, but there was actually careful planning behind each placement. He was creating a foundation that would work with natural forces rather than against them. The first part of his unconventional shelter was barely visible, just a ring of fitted stones that looked like debris from a distance. But Marcus was building according to principles he had learned not from engineering textbooks, but from studying how humans had survived on Earth before they developed advanced technology. Every stone was positioned to catch or deflect wind in specific ways. The spaces between them would channel airflow to create natural cooling during the hot periods and reduce heat loss when temperatures dropped. Marcus, our equipment shelter is approaching completion phase. Where will you install your life support systems? Right here, Marcus said, patting the ground in the center of his stone circle. There are no mounting points for the atmospheric processors. The fusion reactor requires a stable platform. Marcus continued working, now gathering dried organic material he had found trapped against some of the larger rock formations. The reactor stays offline unless we absolutely need it. Same with the processors. Crixvel's 4 eyes blinked in sequence, a sign of extreme confusion among his species. Without environmental controls, the shelter cannot maintain habitable conditions. Internal temperature will fluctuate beyond acceptable parameters. Air quality cannot be guaranteed. Maybe. Or maybe we don't need to control everything if we understand how things work naturally. Marcus was now weaving the dried plant matter into rough mats, following techniques that humans had used for thousands of years before they ever left Earth. The material was surprisingly strong and flexible, and when layered properly, it could provide insulation while still allowing air circulation. Your methods appear to be based on pre-technological approaches. Such techniques are studied in archaeological contexts, not practical applications. Sometimes the old ways work better than new ones. Depends on the situation. As the day progressed, the contrast between the two approaches became increasingly obvious. Crixvel's technological shelter rose from the ground like a monument to galactic engineering. It had perfectly smooth walls, regulated internal atmosphere, and enough computational power to maintain optimal living conditions regardless of external weather. The structure looked like it could have been transported from any civilized world and dropped intact onto this barren planet. Marcus's construction looked like nothing more than organized debris. His stone foundation was now supporting a loose framework of salvaged metal pieces from their supply kit, but instead of using them as intended, he had bent and shaped them to work with the wind patterns he had observed. The dried plant material was woven between the metal supports, creating walls that seemed far too thin and porous to provide any real protection. "I must document your approach for the final assessment report," Crixvel said, recording images of Marcus's primitive-looking construction. "However, I cannot recommend this methodology for mission-critical applications." "That's fair. Let's see how both approaches work overnight." As the alien sun began to set, the temperature started dropping rapidly. Crixvel's shelter automatically adjusted its internal climate controls, maintaining a comfortable environment regardless of external conditions. The fusion reactor hummed steadily, providing consistent power to all systems. Marcus's shelter had no visible power source and no technological systems at all, but as darkness fell and the temperature continued to drop, something unexpected began happening. The stones he had so carefully selected and positioned began releasing the heat they had absorbed during the day. The organic materials created layers of insulation that trapped warm air while allowing enough circulation to prevent stuffiness. Most surprisingly, the structure actually seemed to improve as conditions became harsher. The wind that threatened other shelters was channeled and redirected by Marcus's design, creating airflow patterns that helped maintain comfortable temperatures without any energy input. "Internal readings show your shelter maintaining stable conditions," Crixvel observed with apparent surprise. "How is this possible without environmental controls?" Marcus was sitting comfortably in his primitive-looking structure, completely protected from the harsh planetary conditions. The planet's been running this same experiment for millions of years. I just had to figure out what it learned. The second day brought new challenges that tested both approaches to survival. A massive dust storm approached from the eastern horizon, a wall of swirling red particles that stretched from ground to stratosphere. The weather monitoring systems in all the technological shelters immediately triggered emergency protocols. Across the testing area, teams began sealing their habitats and switching to full environmental isolation. The crystalline helix pair retracted their geometric structure into its most compact configuration. The Zephyrians reinforced their carved shelter with additional gravitational barriers. Every team relied on their technology to create perfect isolation from the hostile environment. "Emergency protocols activated," Crixvel announced as his shelter's systems detected the approaching storm. "All external sensors retracting. Switching to internal atmosphere recycling." The fusion reactor will maintain full power to environmental systems until the storm passes. Marcus was outside his primitive shelter, making what appeared to be last-minute adjustments to his stone and plant construction. Instead of sealing it against the storm, he seemed to be opening it up, creating additional channels and gaps in the walls. Marcus, you must take shelter immediately. The storm will carry abrasive particles at velocities exceeding safety parameters. Your structure cannot provide adequate protection. Actually, I think it can, but not by keeping the storm out. Marcus finished his modifications and retreated to the interior of his shelter. From the outside, it looked completely inadequate to handle the approaching weather disaster. The walls had obvious gaps, the roof was a loose weaving of organic materials, and the entire structure seemed to sway in the increasing wind. Your approach violates fundamental survival principles. A shelter must create a barrier between inhabitants and hostile environmental conditions. Sometimes it's better to work with the environment instead of fighting it. The storm hit with devastating force. Hurricane-velocity winds carried millions of tons of abrasive dust particles that would strip paint from metal and clog any mechanical system. The sound was deafening, like standing inside a waterfall of sandpaper. Visibility dropped to zero as the world disappeared behind walls of swirling red dust. Crixvel's technological shelter performed exactly as designed. Its sealed hull protected them from the abrasive particles, while internal systems maintained perfect atmospheric conditions. The fusion reactor worked harder to power the environmental controls, but that was expected and accounted for in the design specifications. All systems operating within normal parameters, Crixvel reported. Storm duration estimated at 6 to 8 hours based on meteorological analysis. Inside Marcus's primitive shelter, conditions were surprisingly comfortable. The stone foundation had been designed to let the wind flow through in specific patterns that actually stabilized the structure, rather than threatening it. The loose woven walls filtered the worst of the dust particles while allowing enough airflow to prevent pressure buildup that could collapse the shelter. Most remarkably, Marcus had somehow arranged his construction so that the storm's energy was being captured and used. The channeled airflow was driving a simple ventilation system that kept fresh air circulating. The filtered dust was being deposited in specific areas where it actually improved the insulation properties of the walls. How is your shelter remaining stable? Crixvel asked, monitoring their surroundings through his advanced sensor array. External conditions exceed the structural limits of your materials. The storm isn't trying to destroy the shelter. It's just following the path of least resistance. I made sure that path goes through the structure in ways that make it stronger instead of weaker. Marcus's approach was fundamentally different from every other team's strategy. While they fought against the environment using advanced technology, he had found ways to cooperate with natural forces. His shelter was actually improving during the storm, becoming more stable and comfortable as the extreme weather tested and refined its design. The storm raged for 7 hours, battering every structure on the planet's surface. When it finally passed, the assessment took on a new dimension. Most of the technological shelters had performed adequately, but showed signs of stress and component wear. The crystalline helix habitat had developed small cracks from pressure variations. The Zephyrian shelter required gravitational field recalibration after the storm's electromagnetic interference. Crixvel's shelter had functioned perfectly, but the fusion reactor had consumed nearly 30% of its fuel reserves, maintaining environmental systems against the harsh conditions. Storm passage complete. Beginning post-event system diagnostics. Marcus emerged from his primitive shelter looking completely comfortable and refreshed. His structure showed no damage from the storm. In fact, it appeared more solid and refined than before, as if the extreme weather had been part of the construction process rather than a threat to survival. Your shelter appears unchanged by the storm conditions, Crixvel observed with growing puzzlement. How did primitive materials withstand forces that stressed advanced engineering systems? They didn't withstand the forces. They used them. There's a difference between being strong enough to resist something and being smart enough to make it work for you instead of against you. Marcus began making new modifications to his shelter, incorporating some of the dust that had been deposited during the storm. The particles contained minerals that could be processed into stronger binding, agents using simple chemical techniques that required no advanced technology. I am beginning to understand your methodology, Crixvel said slowly. You are not attempting to create an artificial environment. You are adapting to the existing conditions. More than that, I'm learning to speak the planet's language. Every world has its own way of handling energy, materials, weather patterns. If you can figure out how it works, you can work with it instead of against it. Around them, other teams were beginning their post-storm repairs and system maintenance. The technological approach had protected them from the immediate threat, but it came with ongoing costs in power consumption, component wear, and resource depletion. Marcus's approach was actually gaining strength from the same forces that stressed the advanced systems. His shelter was now better insulated, more aerodynamically stable, and required no external power to maintain comfortable living conditions. This raises questions about standard survival protocols, Crixvel admitted. If primitive techniques can outperform advanced technology under certain conditions, perhaps our training approaches require reevaluation. Maybe. Or maybe we just need to remember that technology is supposed to help us solve problems, not replace our ability to think about them. The third day presented an unexpected challenge that would truly test the fundamental differences between technological and adaptive approaches. As dawn broke over the alien landscape, Crixvel's sophisticated monitoring equipment detected an alarming development. The planetary magnetic field was experiencing severe fluctuations, creating electromagnetic pulses that were systematically disabling electronic systems across the testing area. Critical malfunction detected in multiple primary systems, Crixvel announced with obvious concern as his displays began flickering and failing. The fusion reactor is experiencing power regulation failures. Atmospheric processors showing cascade errors. Emergency backup systems are not responding to control inputs. Across the testing ground, similar crises were unfolding for every technologically dependent team. The crystalline helix habitat lost its geometric stability as its control systems failed. The Zephyrian gravitational manipulators shut down completely, leaving their carved shelter vulnerable to structural collapse without artificial support. Marcus watched calmly as the electromagnetic storm wreaked havoc on advanced technology, while his primitive shelter remained completely unaffected. Looks like the planet has one more lesson to teach us. This is a disaster scenario. Without functioning life support systems, survival becomes critically dependent on emergency protocols. I must attempt manual restart procedures for essential equipment. Crixvel began working frantically with backup diagnostic tools, following academy training for technological system failures. His species had developed sophisticated redundancy protocols for exactly this type of crisis. But every backup system relied on electronic components that were being systematically disrupted by the electromagnetic interference. Manual overrides are not responding. The magnetic field fluctuations are preventing stable operation of any electronic systems. This situation was not covered in standard survival training scenarios. Marcus continued his morning routine of checking and adjusting his shelter, completely unaffected by the crisis that was crippling every other team on the planet. It wouldn't be covered in standard training because standard training assumes you'll always have working technology. Without technology, advanced civilization cannot function. These are fundamental tools necessary for survival in hostile environments. Maybe for some species, but humans survived for hundreds of thousands of years before we invented any of this stuff. We learned to work with what was available instead of depending on what we could build. The electromagnetic interference was getting worse, creating a feedback loop that disabled even the most hardened military-grade systems. Across the testing area, teams were facing genuine survival crises as their life support systems failed one by one. The assessment had suddenly become much more serious than academic evaluation. Marcus's shelter not only remained stable but seemed to be functioning better than ever. Without any electronic components to fail, it was completely immune to the electromagnetic problems that were crippling advanced technology. The natural heating and cooling systems continued working perfectly. The air filtration through organic materials was unaffected. The structural integrity actually improved as the materials continued adapting to environmental conditions. I do not understand how you anticipated this scenario, Crixvel said, struggling with equipment that refused to respond to any commands. The electromagnetic interference patterns were not predictable based on initial planetary surveys. I didn't anticipate it specifically, but when you build something that depends entirely on complex systems, You're vulnerable to anything that can disrupt those systems. When you build something that works with natural processes, it keeps working even when technology fails. Marcus began expanding his shelter using techniques he had refined over the past 2 days. Without access to nanoconstructors or fusion-powered fabrication systems, he relied on manual manipulation of natural materials. His hands had learned to shape stone and organic matter with precision that matched advanced manufacturing tools. Your construction methods appear increasingly sophisticated despite their primitive basis, Crixvel observed, watching Marcus create complex joints and support structures using only basic tools and natural materials. How is such precision possible without measurement devices or fabrication assistance? Practice, and paying attention to how materials want to behave instead of forcing them to do things they're not designed for. The electromagnetic storm continued. For hours, creating cascading failures throughout the high-tech shelters. Emergency supplies became inaccessible when powered storage systems failed. Climate control stopped working, leaving inhabitants vulnerable to temperature extremes. Communication systems went offline, preventing coordination between team members. Marcus's primitive approach faced none of these problems because it had never relied on vulnerable systems in the first place. His shelter maintained comfortable conditions through passive solar heating, natural insulation, and airflow patterns that required no power or control systems. His water collection system used gravity and condensation rather than powered purification units. I must admit that your methodology demonstrates significant advantages under current conditions, Crixvel said reluctantly. However, these are exceptional circumstances. Under normal conditions, technological approaches provide superior performance and comfort. That's true, but exceptional circumstances have a way of happening when you least expect them. And when they do, the difference between surviving and not surviving often comes down to how well you can adapt when your preferred tools stop working. Marcus was now assisting other teams whose high-tech solutions had failed completely. His primitive tools and techniques were suddenly the most advanced technology on the planet because they were the only systems still functioning. He helped the crystalline helix pair create emergency shelter using natural materials and basic engineering principles that required no electronic components. Your knowledge appears to encompass construction techniques that are not included in standard academy curriculum. One of the crystalline beings observed through translation protocols that still functioned on backup power. Most of what I know isn't taught in schools anymore. We call it primitive technology, but it's really just technology that's been tested for thousands of years instead of decades. It works because it's had time to evolve and improve through actual use, rather than theoretical optimization. The electromagnetic interference finally began subsiding as the planetary magnetic field stabilized. But the damage to technological systems was extensive. Most teams faced the remainder of the assessment period with severely compromised equipment and no way to repair or replace failed components. Marcus's shelter had not only survived the crisis unaffected, but had actually improved during the emergency. The natural systems had continued optimizing themselves while technological systems were failing. The structure was now more efficient, comfortable, and resilient than when he had started building it. I am forced to conclude that your approach demonstrates superior reliability under adverse conditions, Crixvel admitted as he surveyed his disabled equipment. The technological solutions that seemed obviously superior have proven vulnerable to circumstances that do not affect primitive methodologies. It's not about primitive versus advanced. It's about understanding the difference between complicated systems and robust ones. Complicated systems can do amazing things when everything works perfectly. Robust systems keep working even when conditions aren't perfect. Marcus looked around at the other teams struggling to adapt to their equipment failures, then back at his partner who was still trying to restart critical systems. Besides, the best solution usually combines both approaches. Use technology where it provides real advantages, but don't let it replace fundamental skills that work regardless of circumstances. As the final day of assessment approached, Commander Zeth Kalar received unprecedented reports from the monitoring stations orbiting the test planet. The electromagnetic interference had disabled most surveillance equipment. But the few functioning sensors were detecting something extraordinary happening at one of the test sites. Impossible readings from Sector 7, reported the ship's science officer. Energy signatures suggest a structure that is somehow generating power from ambient environmental conditions rather than consuming stored resources. Run diagnostics on the sensor array, the commander ordered. Equipment malfunction is the most likely explanation for anomalous readings. Diagnostics complete. Sensors are functioning within normal parameters. The readings appear to be accurate. Down on the planet's surface, Marcus's shelter had evolved far beyond its humble beginnings as a simple circle of stones. Through 3 days of continuous refinement and adaptation, it had become something that challenged fundamental assumptions about the relationship between technology and survival. The structure now covered an area 3 times larger than the original foundation, but it accomplished this expansion without using any additional manufactured materials. Instead, Marcus had learned to work with natural processes that were continuously available on this alien world. Wind-driven systems moved dust and small particles to locations where they formed natural mortar. Solar heating and cooling cycles drove expansion and contraction patterns that actually tightened joints and improved structural integrity. Your construction has achieved functionality that exceeds our original technological shelter, Crixvell observed with amazement. Internal temperature remains optimal, air quality is superior to processed atmosphere, and the structure appears to be self-maintaining. It's not self-maintaining. It's learning. Every environmental change teaches it something new about how to work better with local conditions. Marcus had discovered something that galactic civilization had forgotten in its rush toward technological advancement. Instead of imposing artificial solutions on natural problems, it was possible to understand and cooperate with the underlying processes that had shaped worlds for millions of years. His shelter now included integrated systems for water collection, food storage, waste processing, and energy generation that operated entirely through passive natural forces. Rain was channeled through carved stone gutters into filtration systems that used layers of sand, charcoal, and organic materials to produce clean drinking water. Organic waste was processed through carefully managed decomposition that generated heat for warmth and nutrient-rich soil for growing food. Most impressively, the structure had begun generating electrical power through piezoelectric effects in certain crystalline stones that Marcus had discovered and incorporated into the foundation. The constant micro-movements from wind and thermal expansion created small but steady electrical currents that could power basic devices. This is unprecedented, Crixvell said, recording detailed measurements of the power generation system. You have created sustainable technology using only materials available on the planetary surface. The materials were always here. I just had to figure out how they wanted to work together. Word of Marcus's achievement was spreading among the stranded teams. With most of their technological systems still disabled, they began visiting his shelter to understand how primitive techniques were outperforming advanced galactic engineering. The visits revealed something more significant than innovative construction methods. Marcus had not simply built a better shelter. He had demonstrated an entirely different approach to problem solving that combined careful observation, adaptive thinking, and willingness to work with natural systems rather than against them. His methods could be learned and applied by any species, regardless of their technological capabilities. You must document these techniques for inclusion in academy training protocols, urged one of the Zephyrian cadets whose gravitational shelter had failed completely. Such knowledge could revolutionize survival training across all military branches. The techniques aren't really the important part, Marcus explained while helping repair another team's emergency shelter, using woven organic materials and fitted stone joints. The important part is learning to pay attention to how things actually work, instead of how we think they should work. Marcus had begun teaching basic construction principles to other teams, but the lessons went far beyond building techniques. He was showing them how to observe environmental patterns, test materials through direct experimentation, and adapt designs based on real-world performance rather than theoretical specifications. I am beginning to understand why human military units maintain high effectiveness rates in diverse operational environments, Crixvell commented while practicing stone-fitting techniques under Marcus's guidance. Your species appears naturally inclined toward adaptive problem-solving rather than standardized procedural implementation, maybe, or maybe we just remember what it was like before we had machines to do our thinking for us. As the assessment period entered its final hours, Marcus's primitive shelter had become the most advanced structure on the planet. It provided superior comfort, complete sustainability, and reliable operation under all conditions they had encountered. More importantly, it could be replicated and improved by anyone willing to invest the time to understand local conditions and natural processes. The contrast with technological approaches was striking. Advanced systems had provided excellent short-term performance, but proved vulnerable to equipment failures, resource depletion, and unexpected environmental challenges. They required continuous external support and offered no way to improve or adapt based on experience. Marcus's natural approach had started slowly but improved continuously throughout the assessment period. It had turned every challenge into an opportunity for optimization and had achieved performance levels that exceeded original design specifications without consuming any non-renewable resources. Final assessment commences in 2 hours, came the announcement from orbit as communication systems came back online. All teams prepare for extraction and evaluation. Marcus looked around at his evolved shelter, then at the friends he had made among the other species during their shared crisis.
You know what the real lesson is here?
What? Crixvel asked. It doesn't matter how advanced your technology gets. If you stop understanding the fundamentals of how things work, you become completely dependent on systems that can fail when you need them most. But if you understand the principles behind the technology, you can adapt and survive even when the fancy equipment stops working. Marcus began carefully dismantling sections of his shelter, not because it was required, but because he wanted to leave something behind for the planet that had taught him so much. The stones would remain, positioned to continue their slow dance with wind and weather. Future visitors might notice the patterns and learn something about working with natural forces instead of fighting against them. Are you not concerned about receiving lower evaluation scores for using primitive methodologies? Crixvel asked. Marcus smiled as he packed his simple tools. I think the planet already gave us our real evaluation. Everything else is just paperwork. The debriefing chamber aboard the Convergence buzzed with unprecedented activity as teams filed in for final assessment. Commander Zeth Kalar had never seen such animated discussion following a survival evaluation. Cadets from different species were sharing techniques, comparing approaches, and questioning fundamental assumptions about military engineering doctrine. Before we begin individual team assessments, the commander announced, I must address the unusual circumstances that developed during this evaluation cycle. The electromagnetic interference was not part of the planned testing scenario and has required complete re-evaluation of standard assessment criteria. Marcus sat beside Crixvel in the front row, both wearing simple academy uniforms that looked identical to every other cadets, but the conversations happening around them suggested that something significant had changed during their time on the planet's surface. The Zephyrian team has requested permission to incorporate primitive construction techniques into their advanced gravitational engineering curriculum, reported the academic liaison. The Crystalline Helix delegation wants to establish exchange programs focused on adaptive problem-solving methodologies. Commander Zeth Kalar's 4 eyes focused on Marcus with intense interest. Cadet Chen, your approach to the survival assessment has generated considerable discussion among the evaluation board. Please explain your decision to abandon standard technological protocols in favor of what appears to be pre-industrial construction techniques. Marcus stood, aware that his response would influence not just his own graduation, but potentially reshape how survival training was conducted throughout galactic civilization. Sir, I didn't abandon technology. I used the most advanced technology available, which turned out to be the planet itself. Elaborate. Every world is essentially a massive, self-maintaining system that has been solving engineering problems for millions of years. Instead of fighting against those solutions, I learned to work with them. The planet had already figured out how to handle temperature regulation, structural stability, resource processing, and energy generation. I just had to understand the language it was using. The commander's expression remained neutral, but several other faculty members were taking detailed notes. And you believe this approach has military applications beyond academic survival exercises? Sir, during the electromagnetic crisis, every high-tech system failed simultaneously. Teams with the most advanced equipment became the most vulnerable, because they had no backup methods when their primary tools stopped working. Meanwhile, techniques that humans developed thousands of years ago continued operating perfectly because they don't depend on vulnerable components. Crixvel stood beside his partner. Commander, I must support Cadet Chen's assessment. During the crisis period, his primitive methodologies demonstrated superior reliability and adaptability compared to standard technological approaches. His shelter not only survived conditions that damaged advanced systems but actually improved its performance during adverse events. The implications are significant, added the crystalline helix representative. If natural techniques can outperform advanced technology under certain conditions, our entire approach to military engineering may require fundamental reconsideration. Commander Zeth Kalar accessed his evaluation files, reviewing data that challenged decades of established doctrine. According to orbital monitoring, your construction generated power, processed resources, and maintained optimal living conditions using only materials available on the planetary surface. How is this possible without manufactured components? Marcus had expected this question. Sir, we assume that advanced technology is always superior to natural processes, but that's only true when both systems are working perfectly. Natural systems evolve through millions of years of testing under real-world conditions. They develop solutions that work reliably even when circumstances change in unexpected ways. But surely technological systems provide capabilities that natural processes cannot match. Absolutely, sir. The fusion reactor can generate more power than my piezoelectric stones. The nanoconstructors can build faster than manual techniques. But when the reactor fails or the constructors malfunction, you're left with nothing. When natural systems encounter problems, they adapt and find new ways to keep working. The academic liaison raised a concern that many faculty members shared. Are you suggesting that military training should abandon technological advancement in favor of primitive survival techniques? No, sir. I'm suggesting that we need both. Use advanced technology where it provides clear advantages, but maintain fundamental skills that work regardless of technological availability. The best approach combines both methodologies instead of depending entirely on either one. Marcus gestured toward his fellow cadets from different species. During the crisis, we learned that every species has developed unique solutions to environmental challenges. Humans figured out adaptive construction and resource management. The Zephyrians understand gravitational effects that we can barely measure. The crystalline helix species has mastered geometric principles that our computers struggle to calculate. When we shared these different approaches instead of competing with them, we created solutions that were better than anything any single species could develop alone. That's the real lesson from this assessment. Commander Zeth Kalar considered the implications. Military doctrine emphasized standardized procedures and technological superiority, but the recent crisis had revealed critical vulnerabilities in that approach. Marcus's success suggested that adaptability and fundamental understanding might be more important than advanced equipment. The evaluation board will need time to consider these findings, the commander announced. However, I can provide preliminary assessment results for all teams. The commander activated his display system, showing performance metrics that surprised everyone in the chamber. Under standard evaluation criteria, the technological approaches achieved acceptable performance ratings during normal operations. However, during the electromagnetic crisis, these same approaches experienced catastrophic failure rates exceeding 90%. Cadet Chen's primitive methodology achieved optimal performance ratings throughout the entire assessment period, including superior efficiency during the crisis phase. More significantly, the natural system showed continuous improvement over time rather than degradation. Marcus felt relief wash over him, but the commander wasn't finished. Furthermore, teams that incorporated adaptive techniques shared by Cadet Chen showed dramatic performance improvements during the recovery period. This suggests that such methodologies can be learned and applied across species boundaries. The commander paused, looking directly at Marcus. Cadet Chen, your approach has demonstrated capabilities that challenge fundamental assumptions about military survival doctrine. The evaluation board is recommending that you be assigned to develop new training protocols that integrate adaptive techniques with standard technological approaches. Sir, I'd be honored to contribute to training development. But I think the most important thing is making sure we don't lose sight of the basic principles behind our technology. Understanding why things work is more important than just knowing how to operate them. Crixvel stepped forward. Commander, I request assignment to the same development program. The integration of technological and adaptive approaches requires collaboration between different methodological perspectives. Granted. Additionally, the Academy will be establishing exchange programs with multiple species to develop comprehensive adaptive survival curricula. As the formal assessment concluded, Marcus found himself surrounded by cadets from different species, all eager to learn more about natural construction techniques and adaptive problem solving. But the conversations quickly moved beyond building methods to deeper questions about the relationship between technology and understanding. Your species appears to maintain knowledge that others have forgotten in pursuing technological advancement, observed one of the Zephyrian cadets. How do humans preserve such primitive wisdom alongside modern capabilities? Marcus considered the question carefully. Maybe because we remember that we're still the same species that survived ice ages and planetary disasters long before we had machines to help us. The technology changes, but the fundamental challenges of adapting to unexpected conditions remain the same. The key is remembering that technology should make us more capable, not more dependent. When you understand the principles behind your tools, you can adapt when circumstances change. When you only know how to operate the tools, you're helpless if they stop working. Commander Zethkalar dismissed the assembly, but the real discussions were just beginning. Word of the assessment results was already spreading throughout the fleet, generating interest from military strategists, engineering corps, and survival training specialists. Marcus walked to the observation deck, looking back at the planet that had taught him so much about the relationship between innovation and tradition. Somewhere down there, the stones he had carefully positioned were continuing their slow dance with wind and weather, ready to teach the same lessons to anyone willing to pay attention.